Alright, welcome to a past exam paper that was written in Gauteng in the year of 2024 in the month of June. So this is paper 1. We are going to start off with question 2, whereby you are required to simplify. So they say 2b open bracket b minus 5c close bracket squared. We both know that this squared means what? You must write b minus 5c twice. So let's answer. So I start by saying that I've got 2b open bracket b minus 5c and open bracket again b minus 5c close bracket. Now I write my equal sign. Now with this 2b, I'm not going to do anything at this point in time. I'm just going to say 2b. Then now I start to multiply these, which are in the brackets. So now b multiplied by this b, it gives me b squared. And positive times negative, I get a negative sign. 5c multiplied by b, it gives me 5bc. Then I'm done multiplying everything with this b, which is found in this bracket. I come to this negative 5c. Now I say negative multiplied by positive, it gives me a negative. And then 5c multiplied by b, it gives me 5bc. Then I come negative multiplied by negative, that's a positive. Then 5 by 5, that's 25. And c multiplied by c, that's c squared. Close the bracket. Now, if you observe here, I've got negative 5b and negative 5bc, negative 5bc and negative 5bc. These two, they are like terms. So on the next stage now, I write 2b open bracket b squared. Negative 5 gives me negative 10. So I've got negative 10bc plus 25c squared. Now, only now do I get to multiply with this monomial outside. Now I say 2b multiplied by b squared, it gives me 2b cubed. Why did I say 2b cubed? Because your law number 1 says that when you've got a to the power m multiplied by a to the power n, the bases are identical, you must add the exponents, which is now a to the power m plus n. So in this instance, because here I've got b to the power 1 multiplied by b to the power 2. Now I add the exponent, so basically it's b to the power 1 plus 2, which is equals to b to the power 3, right? Alright, so now that's how I got this b to the power 3. Now I say positive multiplied by negative, I get a negative sign. Now I say 2 multiplied by 10, it gives me 20. I've got b here, there is b there. This is b to the 1, b to the 1. 1 plus 1 is equals to 2. So I get b squared. Then there is c. There is no c there, so I just write c as is. Then now I go to the last term. Positive and positive is 2, gives me a positive. And 2 multiplied by 25, I get 50. I've got b, and here I've got c squared. So b c squared. These 3 terms, there is nothing which is identical to other. In other words, these 3 terms are unlike terms. So this is the final answer, and you get your 2 marks. Done. Okay. Let's go to the next question. What was the next question talking about? The next question wanted us to simplify this what? This exponential expression. We're given 3 to the power x. So 2.1.2, we say 3 to the power x minus 2 multiplied by 3 to the power x minus 1 all over 3 to the power x plus 2 plus 2 multiplied by 3 to the power x plus 1 there. This is all over. So the first thing that I'm going to do, I need to what? I need to factorize. Why am I going to factorize? Because here I've got a negative and there I've got a positive. So I can't do anything when there is a positive and a negative except for what? Except for factorizing. So I write my equal sign. Do I have any common terms here? Oh yes, I do have. But let me first simplify. What do I want to simplify? I want to reverse law number 1 here and law number 1 there and law number 1 elsewhere there. Why am I saying I want to reverse it? Remember what I said a moment ago? A to the power m multiplied by a to the power n. We say a to the power m plus n. Now, when you are given 3 to the power x minus 1 here, it means that you are having 3 to the power x multiplied by 3 to the power negative 1, which is what gave you 3 to the power x minus 1, like that. So now I don't want it to continue looking like this. I need to reverse it to this state. So if I come here, I rewrite 3 to the power x minus 2 multiplied by, already now you know that I must say multiplied by 3 to the power x multiplied by 3 to the power negative 1. Why am I doing this? It will make it easier for me to identify common factors. So if I'm having x plus 2 here, it means that I had 3 to the power x multiplied by 3 to the power 2 plus 2 multiplied by 3 to the power x multiplied by 3 to the power 1. Now if I go to the numerator, I see 3 to the power x here, I see 3 to the power x there. These two, they don't look alike. So which means 3 to the power x is my common factor. I factor it out. So now I write 3 to the power x here. I open the bracket. So obviously for me to get this 3 to the power x, I say 3 to the power x multiplied by 1. So there is a 1 here, right? Minus what? Minus 2, which is here. And here there's 3 to the power x, but it has already been factored out here. So which means that I'm now left with 3 to the power negative 1. So multiplied by 3 to the power negative 1. I close the bracket all over. If I come here, I've got another 3 to the power x and another 3 to the power x. So 3 to the power x, once again, is a common factor. I open the bracket. For me to have this 3 to the power x, I multiplied with 3 to the power 2. So which means the factor which is not common, which is remaining, is 3 to the power 2. Plus, here I've got 2, so I write 2. Multiplied by, this is already outside, so I don't rewrite it. Multiplied by 3 to the power 1. 3 to the power 1, like that. Now observe, here what do I have? I've got 3 to the power x and 3 to the power x. And the interesting part now is that we've got brackets, which means this is multiplying with that, this is multiplying with that. So now, if I'm seeing identical things and I've got multiplication brackets, it means these identical things, they can cancel. Meaning to say that now I'm left with what is inside the brackets. Now here I've got 1 minus 2 multiplied by 3 to the power negative 1, right? So now I write my 1, and I've got a minus. Here, observe, I've got a minus 2 multiplied by this 3 to the power minus 1. I rewrite it as 1 over 3, right? So what can I do with these 2? These 2, let me rewrite it as an improper fraction. So 2 over 1. Remember, this dot which is here means multiply, meaning to say that these 2 fractions must multiply before I can do anything with this positive 1, which is all over. Now I come here, I've got 3 to the power 2. What is 3 to the power 2? That's 9. Plus, I've got 3 to the power 1, which is 3 multiplied by 2. 3 times 2 is 6, so I've got what? I've got 6 here. Now, on the next stage, I still rewrite my 1. I say minus. Now I say 2 multiplied by 1, which gives me 2, over 1 multiplied by 3, it gives me 3. Now, remember, 9 plus 6 gives me what? 15. So I've got 15 here. Now, what I want you to remember is the fact that when I have 2 over 3 here and I've got one whole number, this one whole number, I can write it as what? As a fraction. And where do I get the denominator? I look at the fraction that I've been given here. So I've got 3. So now I come and I write 3 over 3 minus 2 over 3 all over 15, which is equals to, oh, wait a minute, I didn't write 3, I wrote 2 here. Now, since I've got identical denominators, it means that on my fraction, I've got what? On my denominator, I've got 3. So I've got 3 here over, now I say 3 minus 2, which is equals to 1. Now, instead of writing this division, I now write it like this. Divided by what? 15 over 1. Now I'm going to use what we call the KCF method. What is the KCF method? The KCF method simply implies that I must keep this fraction. So I must keep the 1 over 3. So I keep the 1 over 3 here. Then I must change the sign, so I change the division sign to a multiplication sign. Then I must flip here 1 over 15, so the denominator becomes the numerator, numerator becomes the denominator. So I now have got 1 over 15 here, which is equals to, now I say numerator multiplied by numerator 1 by 1 is equals to 1 over 3 multiplied by 15 is equals to 45. And just like that, I have found my answer. Alright, please do join me on the next video, so that when I'll be now answering the rest of the questions. If you have found this video to be helpful, please do consider to subscribe, like, share, and comment. Thank you.